Okay.
Yeah. Hello, hi, good afternoon. My name is Algorizmi Prasetyo, and I will be presenting my facial expression recognition song suggester. Why did the laser pointer not work? I don't know, but yeah. Anyways, introduction. Music has been observed to help reduce psychological problems such as depression, stress, and anxiety. Now, whenever you're feeling sad, well, personally for me, whenever I'm feeling sad, I like putting on sad songs because sometimes I feel like a piece of garbage, and sad songs overall just help me alleviate what a piece of garbage I feel like. And because it's calming, it's low energy, it just feels right for that moment. Music recommendation systems are programs that suggest music to listeners based on their information. So yeah, there's like collaborative filtering, which suggests things based on people that are similar to you. So people that listen to the same artist as you, then it will suggest to you like artists that they listen to. Now, also, I want to show of hands. How many people use streaming services, like for songs? It's like, what? Ah, yeah, see, everyone. Okay, now Spotify is estimated to have 456 million monthly active users with over 100 million active subscribed users. Now, that only counts for Spotify, so like imagine for also Apple Music and then like whatever else, like Deezer. And yeah, so the problem statement that we're trying to fix here is that the paradox of choice makes it difficult to choose a song based on what you're feeling. Because when you're sad, but you want to discover new music, which is admittedly kind of like it's quite a rare situation, but it's not rare for me, and I'm an important person. So yeah, the paradox of choice makes it difficult to choose a song. I want to discover new music, but I don't want to make the effort of discovering something new. So yeah. So first, the research method. So what we did was what resources were already available. So like the literature review that we did, and then some research methods, and then the experiments. So like what did we do, which was the prototyping, and then the testing of the actual prototype. So what did I create to further exemplify like the resources that we researched into, and then the data collection. So the primary things that we tested were the primary things that we collected were the testing, and then the secondary things we collected were online journals and online articles. So here's some facts about the project that I did, as well as in general. So first, a dataset by Vatsal Mavani, which was extracted from the Spotify API, which is an API that has the entire list of songs, and then it gives them values, and some of those certain values can kind of give you a background as to what that song is. So there's a value called valence, which assumes how happy a song sounds based on the energy, and then there's also energy itself. So like how energetic a song is, how loud and also loudness, how loud a song can be. And then also research, yeah, as I said, research has shown that people in sad moods tend to prefer sad music, as shown by Yoon et al. And then music recommendation system work through different ways. Collaborative filtering, I already said that. And then facial recognition technology is usually done through machine learning by training on labeled images of faces. So machine learning is fed multiple images of different types of faces from different races, gender identities, especially with different emotions, and then it will eventually like figure out the differentiation between those emotions and then how it can detect those emotions. So here's the program process that we had. So first, it would perform an image capture, which is done through a laptop webcam, and then it uses OpenCV to record a video, and then through that video, it would take a frame of what's recorded, and then use that as an image to be fed into Deepface, which the entire thing is run through Python. And Deepface is a machine learning module that is already trained, which cut down a lot of the time that it took to create this project. So because it's already trained, it already knows certain emotions, and then it can also do more capabilities than just that. But for this application, we just use the emotion recognition part. And then for song matching, we use MySQL and matching parameters to certain moods. So as I said, there were certain parameters like valence, energy that can detect, that can kind of like define how that song feels. And so we put the data set into MySQL, and then we match the parameters to certain moods. So like a sad song would have less energy, so we put less than or equal to 0.5, the max value is 1, and then valence is less than 0.4, and the max value is also 1. And then the output is the song curated for the user's mood. So, oh yeah, okay, who's this beautiful guy? Anyways, implementation. So here's me smiling, and then over here is the terminal capture. So it says, you're feeling happy, here's a song that I recommend, and then enter the time period that you want your song to be. Because, well, different songs from different time periods, they sound different. So I said I wanted the song from 1951 to 1970, so I entered 2, and then I got a song from, I had to cut down the screenshot to make it fit into this, but it was from 1960, I believe. So yeah, this song is meant to be a happy song based on the fact that I'm smiling over here. So we did perform testing for this project. So we tested 6 users, which isn't enough to give like a conclusive analysis. However, it is still something. So we tested 6 users of varying races and gender identities and they were asked to test the project 10 times each. 4 of the 6 users said that they enjoyed the songs that were given to them. They enjoyed every single song from those 10 times. They liked it. And then 3 out of 6 users stated that some songs did not match the mood that they got. So let's say that they asked for they tried an angry expression. They got angry, like the angry output back, but then angry, like the song didn't actually sound angry. So yeah, here's the main testing process that we did. So tester tests the program with facial expressions, happy, sad, angry, and neutral. And then the tester listens to the songs that the program gives them, and then the tester answers the questions that were given to them. So here are the pros and cons that we found about this certain project. So the pros is that, well, it's fun to use. Like, who wouldn't want to like just smile and then immediately get a happy song back to them? And it's an easy way to discover new music. So some of you might think like, well, okay, if I'm sad, why would I want to like discover new music? Well, now you can be sad in 86 different cultures because, you know, duh, like it's an easy way to discover new music. And then some of the cons is that, well, it can be inaccurate. A lot of the users did point out that whenever they were trying to perform a happy expression, when they didn't smile with teeth, it just gave them neutral or maybe even sad. So it wasn't actually that accurate. And then also, it's not an exact way to find a song that you will like. Everyone's different. Everyone has different favorite genres. This program just kind of spits out like anything that fits those values. So let's say you only like rock music, well, and then you want a happy song that is rock. Well, it's not a surefire way that you'll get a rock song back because the data set wasn't separated by genres. So yeah. In conclusion, what we did was that we created a facial expression recognition program that can suggest songs. What we found is that, unfortunately, it can be fairly inaccurate. That could be because of the module that we used, which is DeepFace. We suspect that it wasn't trained on enough data. But we also concluded that it's fun to use for everyone. Everyone that tested it stated that they would like something like this in a streaming service that they use. And in future works, if we were going to work on this more, is that we would like to have like connection to streaming services like Spotify through Spotify API. That way it can be more personalized because Spotify API lets you connect to the user's data. So it takes in their listening history and like their likes. So it can be more personalized and it can ensure that the user does enjoy the song that is given to them. And yeah, improvement in the facial recognition portion, possibly through training our own machine learning module, or just using a better machine learning module. We just choose DeepFace to cut for time, and because it was easy to get the point across. So yeah, there's also a demonstration video if anyone would like to watch that. So I think yeah. So here's me performing for. Yeah, this is the happy expression. This is me smiling, and then, as you can see, it will zoom in. Yeah, it says you're feeling happy. Here's a song that I recommend. Now, I want a song from. I think I chose 2020 because well, I'm 19 years old, so yeah. So I chose something from that era, and then I got this song, which is a Spanish song from 2003. Now, this is me trying to perform a sad expression. Now, bear in mind, I am a very sad person, but somehow I kept on getting, well, you're feeling angry. Here's a song that I recommend. So it's, as I said, it's not entirely accurate, even though I was trying the saddest face that I could, with knowing that, well, it could be very inaccurate, and I got angry. So here I try again. Is this even running? Yeah. I answer I think I answered 2, so it gives me, yeah, it gives me an angry song. Actually, no, I answered 3, so yeah, it gives me an angry song from 1988. I listened to the song. Yeah, it made me pretty angry. So yeah. And then there, I wasn't even trying to look sad in one of them, and then I got sad, even though I was doing a very neutral face. And here's me trying sad again, and then I got angry again. So, which proves, yeah, the module that we used isn't very accurate, but it gets the point across. So yeah, now I tried putting in a song from 2020, and yeah, that's it. And that's all for my presentation.